Hi everyone. I want to thank everyone that was able to make it to my small group today where we reviewed writing systems of equations, where we wrote the equations given a real world scenario. We practiced this in order to review for the OMHS 703 quiz. During this time, we didn't get a chance to go through all 4 of the examples I had planned. And that was okay, because one of the reasons is you guys did a great job of participating and interacting, so I'm really glad we had that time. But I did want to create this video, so if any of you wanted to review those extra 2 examples, or even see the first 2 that we did together in class again, you have a nice, easy way to see it all in one video, and it'll be a little bit shorter and more concise than going back and watching the recording. With that being said, I'm going to go over the 2 examples that we did not get to first. So that way, if you were in the live session and that's all you want to see, it's right here at the beginning of the video. But the last 2 examples are the ones that we did get to in class. All right, so let's go ahead and get started here. Yep. All right. Here we have our first example. Whenever I do word problems, the first thing is I go through and read it once just to get the gist. Kristen spent $131 on shirts. Fancy shirts cost $28 and plain shirts cost $15. She bought a total of 7 shirts. Write equations to represent the scenario. When I go through and read it a second time, that is when I'm going to underline all that key information. All right, so I see that Kristen spent $131 on shirts, that the fancy shirts are $28, and then the second type, which is plain shirts, are $15. She bought a total of 7 shirts, and my task is to write equations. All right, for this quiz, since this is the beginning, we're focusing on just writing the equations. So that way, eventually, after you write them, you can either use graphing or elimination to solve and actually find the answer. All right, whenever I go through a problem, the first thing I like to do is identify my variables. So my variables are the 2 pieces of information I'm dealing with. And a lot of times it's that missing information. Okay? When I look at this, I see that we have 2 types of shirts. We have fancy shirts and plain shirts. You can use an X and a Y, but I like to use variables that kind of match the name because it helps me remember what they stand for, which will lessen my chance of making an error. So I'm going to use F for fancy shirts and P for plain shirts. Now, after I read, I can get a little bit more information on what exactly it is. Is it the cost or is it the number? Well, that being said, let's look at our information to figure out whether this is the cost per shirt or whether it's the number of shirts I bought. Well, I see that it tells me the cost per shirt because it's 28 for a fancy, 15 for a plain. So that's not my variable because that's not unknown. I know how much it costs. But what I don't know is how many of each. I know that I bought a total of 7 shirts, but I'm unsure how many of those were fancy and how many are plain. So that right there is specifically my variable. So my F, will it not let me click back in here again? It's being finicky today, I guess, isn't it? There we go. Where F is the number of fancy shirts I purchase, and P is the number of plain shirts. Now that my variables have been determined, the second thing I like to do is find my totals, because by finding the totals, that'll help me set up my 2 different equations. All right, it looks like one of the totals is the amount of money spent on shirts, and my second total is how many shirts were purchased. All right, so one of my totals is going to be $131, and my other total is going to be 7 shirts. The reason I like to label it when I am setting it up is that helps me make sure I get the information in the right place because I have to make sure my labels match. Let's start with the one that deals with money. Well, $131 is the total amount of money spent. I see that I spent $28 for every fancy shirt. So it's $28 times every fancy shirt I purchased. And I purchased plain shirts. Well, and means that's in addition to. So add. Plain shirts cost $15 each, which means it's $15 times the number of plain shirts I purchased. And I can double check this equation by making sure my labels match. Well, I have $28, which is money, plus $15, which is money, equals $131, which is money. The labels match all the way across, which means they belong together. That's a good equation. Now, for my second equation, I'm out of information. I'm out of numbers. I already used up all of my numbers. Well, what is it that adds up to 7 shirts? Yeah, the shirts I bought, the fancy and the plain. That right there is actually just going to be your equation, is the fancy shirts plus the number of plain shirts equals a total number of 7 shirts purchased. And that right there will get us our equation. Okay? Now you could either choose to change these into slope-intercept form and solve by graphing, or you could use the method we learned today and set them up so that way one of your variables eliminated and eliminate them. Okay? And problems like this that are a little bit that take an extra step to eliminate, we're going to work on those on Friday. Okay? All right, excellent job, guys. Let's go ahead and try another example. Oh wait, I actually graphed them for you. My bad. All right, so here we have the graph. Now in order to graph this, I did need to change my variables to X and Y. So I used X for the fancy shirts, Y for the plain shirts. And when they're graphed, I see they cross right here at this point 2, 5. Remember that point at which the lines cross, that is our solution. All right, with ordered pairs, we always have our X first, which means 2 fancy shirts were purchased. And our Y is the second number, which means 5 plain shirts were purchased. And that right there is the only combination that matches both equations. That's the only combination of plain and fancy shirts that equals $131 and also having bought 7 total shirts. Any other combination does not work. All right, now let's go to the next example. All right, Daisy has a piece of string that is 25 feet long that she cuts into 2 pieces. The longer piece Y is 5 feet less than 2 times the length of the shorter piece X. Write equations to represent the scenario. All right, once again, let's underline our key information. All right, I see that she has a piece of string that's 25 feet long, and she cuts it into 2 pieces. The longer piece, which is our Y, is 5 feet less than 2 times the length of the shorter piece X. Oh boy, I'm gonna have to break this down because that's pretty much it. The whole sentence is important, so I'll have to break it down into smaller chunks. And once again, our goal is simply just to write the equations. All right, just like before, my very first task is to identify the variables. Sometimes the word problem tells you the variables, which this one did. This one identifies that our variables are the shorter piece, which is x, and the longer piece, which is y. All right, I'll type this over here just so that way I can see it a little bit better. So x is the shorter piece of string. And then y is the longer piece of string. Okay, there we go. Well, just like before, let's go and see if we have any totals. When I look through this, I only see one total, and that's okay. So let's just start with that equation. I notice that I have a total of a string being 25 feet long. And that I cut the string into 2 different pieces. Well, I know my 2 pieces are that there's a shorter piece x and a longer piece y. Well, if one is shorter and one is longer, that means she didn't cut it in half. So I can't just take 25 and divide it by 2. Well, it's kind of like that last problem with the shirts, that I don't really know what the length of the 2 pieces are. All I know is that I have 2 pieces. So I have my first piece plus my second piece, and together that equals 25 feet. That right there would be your first equation. Now let's get to my second equation. This is one where it didn't give us a total. And when that happens, that means our total is going to be one of our variables, okay? I read this second sentence here, I see that it says the longer piece y is. What does that connection word is mean? Add, subtract, multiply, divide, or equals? Is means equals. So the longer piece is, so is equal to 5 less than. Well, 5 less than means minus, but I have to be careful because I don't want my minus to accidentally become a negative sign or to be with the wrong number. So whenever you see a more than or a less than, that's a turnaround word. That means it's going to go after what comes next, because I'm saying 5 is less than whatever follows my sentence. So I know that that is going to come way at the end and going to be a minus 5, because 5 is less than whatever I'm going to read next. All right, what I'm going to read next is that it is 5 less than 2 times, so that's multiplication, the length of the shorter piece, which is x. All right, it's a little spread out, but I just wrote my equation. So let's bring it down here. And as I do, we'll read it to make sure it matches. So the longer piece y is 5 less than, so I'm going to wait to write that because that comes at the end. What it's less than is 2 times the length of the shorter piece. There we have it. We have 2 separate equations. Now for me, if I look at this and I were to be asked to take the next step and solve and find the length of each string, because one of them is in slope-intercept form, I would choose to solve this by graphing. So convert that top equation into slope-intercept form and graph them. Let's clear this and see what we get when that happens. All right, here we have them graphed. And just as a reminder on this screen, X is the shorter piece, Y is the longer. I see my two lines intersect right here at 10:15. Whenever we have an ordered pair, the X always comes first, which means the shorter piece of string was 10 feet. And the longer piece of string is 15 feet. And that right there is the only combination that satisfies both requirements of it equaling 25 feet total, and that the longer piece is 5 less than twice the shorter. All right, these two examples were the ones that we did not get to in class. So if that's all you wanted to see, you guys are welcome to stop watching the video. But if any of you missed class, or you just want to see those next two examples again, because word problems can be tricky, stick with me, all right? And sorry, my chair is super squeaky again today. We did get some WD-40 on that. All right, here we go. Here's that first one we did in class together. Antonio's school is selling tickets to a spring musical. On the first day of ticket sales, the school sold 3 adult tickets and 9 child tickets for a total of $75. The school took in $67 on the second day by selling 8 adult tickets and 5 child tickets. Write equations to represent the scenario. All right, just like before, let's go through and identify all of that key information. So I see that on the first day, we have 3 adult tickets and 9 child tickets for $75. And then on the second day, we have $67 and they sold 8 adult tickets and 5 child tickets. And once again, my task is to simply write the equations. Okay. Now that that's done, let's think of my variables. All right, with this one, there's a lot of information, so once again, it may be hard for me to tell exactly what the variables mean, but I do know the 2 items I'm dealing with is that there are adult tickets and child tickets. So we can start there in regards to our variable. All right. So we know, well, we don't want to use X, let's use A for adult. So A is adult tickets. And then I know I'm going to use C for then child tickets. All right, now let's go back and read and see what kind of information I'm given to help me know, is this the number of tickets or the price? All right, I see that they sold 3 adult tickets and 9 child. And then they sold 8 and 5. All right, well that means I know how many they sold, but I don't know the individual prices. Because I know the total amount of money I earned, but I don't know the individual price for an adult ticket and a child ticket. That unknown means that will give me more detail for my variables, all right? So specifically, that means that is the cost of adult tickets and then the cost of child tickets, all right? This one's set up pretty nice because each day is its own equation. On that first day, what is my total amount? Well, it's a total of $75. And if it's a total, that means everything is going to be equal to it. Now, what is equal to that? Well, I see that there are 3 adult tickets and 9 child tickets. But it can't just be 3 and 9 because 3 plus 9 is not 75, 3 times 9 is not 75. There's gotta be something else. The variable, that's what it is because it's $75. And right now the 3 and the 9 aren't money. It's just the number sold. But my variables are the cost. So that helps me have an equation that matches up. So there were 3 adult tickets purchased, and A is the cost. So 3 tickets purchased times A times however much it cost. And then 9 child tickets. So 9 tickets were purchased times whatever C, the cost of a child ticket is. And last but not least, what is being done with them? Added, subtracted, multiplied, or divided? Add, because we are having an and there. So it's this and that. They're being combined. They're being added. All right, there's our first equation. Now let's do our second one. All right, let's see what the second day total was. Well, the second day total was $67. So once again, if that's my total, that's on one side of the equal sign, okay? What did they sell this day? Well, here they sold 8 adult tickets. So 8 tickets were sold times A, the price. I see the word and again, which means I'm adding. And then 5 child tickets. So 5 times C, the cost of a child ticket. All right, let's rewrite these so that way it's a little bit clearer. But here we have our 2 equations. And then if you were being asked to solve them, you could solve them to figure out how much those tickets cost for both adults and children. All right, there we go. Let's clear this and check out the graph. All right, once again, to make this work on the graph, I had to change A to X and Y to C. Or wait, C to Y. And remember, whenever you graph a system of equations, that point at which they intersect, at which they cross, is your solution. The first number is our X. So it was $4 for an adult ticket. The second number is our Y. So it was $7 for a child ticket. Now, in looking at this, that doesn't really make sense because usually child tickets are cheaper than adult. So I will make a note to change that for next year. Oops. But hey, life happens. All right, guys, we have one more. A class of 195 students went on a field trip. They took 7 vehicles, some cars and some buses. Each car holds 5 students, and each bus holds 45 students. Write equations to represent the scenario. All right, what we got? So there were a total of 195 students that went on the trip. They took a total of 7 vehicles. Some were cars and some were buses. Those are my 2 types. Each car holds 5 students. Each bus holds 45 students. And just like all the others, my task is to write the equations. All right, what are my variables? Well, my variables are the 2 items I'm dealing with. And I see that I am dealing with cars and buses. Those are my 2 different types of vehicles. Let's use C to represent cars and B to represent buses. All right, now that I know what I'm dealing with, let's check out our information and see exactly what with cars and buses that's dealing with. Okay, so I know how many students there are, and I know that a car can hold 5 and a bus can hold 45. So that means it's not the number of students. I know the number of vehicles, but I don't see anywhere where it tells me how many cars or how many buses. Therefore, that's my unknown. So to be more specific, it is the number of cars that were used and the number of buses. All right, once again, let's look for a total. The first total I see is that there were a total of 195 students. All right, let's go through and pick out any information that matches with that student's label that will go together in that equation. I see that a car holds 5 students and a bus holds 45. Well, my car is my variable C, and it holds 5 students. So 5 times C, because 5 students times every car that's available. And then a bus holds 45. Well, bus is my other variable, B. So 45 students times every bus that is there. And my connecting word is and, which means these are being combined, so I will add. All right, equation number 1 is done. Now let's do equation number 2. My other total is that we have 7 vehicles. Well, what is it that adds up to the 7 vehicles? The number of cars and the number of buses, which, if we look at what we labeled, is my variables. So this, very similar to that very first example we did, is just going to be the number of cars plus the number of buses. And I don't need any coefficients, any numbers with it. So cars, so the number of cars plus the number of buses is a total of 7 vehicles. And that would be it. Those would be our 2 equations. And this would be one where I personally would use elimination, since neither one of them is in slope-intercept form, to solve, if you wanted to solve. But because I know you guys are visual, we just started elimination, I did go ahead and solve it by graphing, just like all the others. All right, here we have it, these 2 equations graphed. I just changed, instead of C, X is cars, and instead of B, Y is buses. So what is the correct combination? All right, our first number in ordered pair is an X, which means there were a total of 3 cars. Our second number in the ordered pair is Y, which means there were 4 buses. So in order to get 195 students to this field trip and only have 7 vehicles, there were 3 cars that went and 4 buses. All right, I hope this helps clear things up for you guys. Please remember that you have 3 attempts on the OMHS 703 quiz. If you've already taken it once, I hope you watch this video and before you take it a second time. And before you use that 3rd time, if you're still not happy with your score, please either send me an email or come to my office hours, which are every Monday and Thursday that school are in session at 4 p.m. And I will be more than happy to give you some more examples and work with you. All right, good luck, guys. Bye.